skills. And the third day, Wednesday, it will be your presentation. You are going to present the model question paper of a subject which you are comfortable or you are teaching currently, according to your university pattern, or if you are autonomous college, according to your college end semester exam pattern. So you have to prepare a question paper right from today evening. You start working, and tomorrow by evening you submit it to AICTE, and we'll invite you on the third day, Wednesday, right from 10:30. It is your day. You are going to share your paper, and the people will be asked to comment on it. Even we'll also participate. It's a good opportunity. It's a good opportunity for you to get the feedback on the question paper you have prepared. So if it's already of a good quality, it will be appreciated. And if there are some deficiency, people will comment and there is opportunity to improve. In any way, it is always good to share, because such an opportunity you will not get. Here you will get to know what type of question paper you are able to set from various experts, as well as experts from other institutions as well. So don't be shy in sharing your question paper. Either the opportunity to learn or opportunity to showcase your talent. Okay. So with these words, I would like to thank AICTE for giving our KL Technological University team to share our experience about the examination reforms. It so happened that in 2018, AICTE constituted a committee under the chairmanship of our Honorable Vice Chancellor Ashok Shettar, and that committee prepared a report, and most of the content is based on the experience or the practices what we are doing at KL Technological University, and report was presented to AICTE Executive Council. They accepted it, and after the AICTE approval, it became a policy document. Then AICTE thought simply printing the policy document and sharing with the institutions or allowing them to download from the AICTE website, it didn't help, because any policy document will have many details which will be missing, which needs to be communicated or shared with the faculty members so that its implementation will be effective. Otherwise, it will become just another beautiful document in the shelf. Since AICTE was very particular about its implementation, therefore, from December 2018, they have been conducting examination reform workshops. We ourselves, our team went to 15 states before COVID-19 and conducted one-day awareness programs. Then the AICTE realized awareness workshops are not sufficient. There should be some more hands-on experiences. Then we started conducting 4 days train the trainer program. But when it was going through, the COVID struck, and since then we are conducting in online mode. Now it has become a 3 days workshop. So with these words, I will start presenting the first session, that is overview of this entire policy document. So supposed to be presented by our Honorable Vice Chancellor Professor Shettar, but on his behalf, I am presenting this, taking this session. So you are seeing here student learning, because as the teachers, as academic administrators, and regulators like AICTE, all are concerned about student learning. And how a student learns? Student learns through the educational experience that we create during the stay on campus. During the 4 years, what he interact with us, during that time, we create educational experience. Through that educational experience, he learns. This educational experience could be through core courses, through elective courses, through laboratory courses, through course projects, mini project, minor project, or final year project, or field visits, industrial visits, or internship. So there are various modes through which we create educational experience during which he developed the ability to apply, ability to solve, ability to how to communicate or how to lead a team, and how to analyze a problem, how to come out with different solutions for a given problem, and how to use modern tools, how to be careful about the environment when proposing a new solutions, engineering solutions, and similarly, looking at the technological trends, how himself or herself has to equip himself for lifelong learning. So all these things we have to communicate or help him to learn through the education experience what we create in 4 year stay of him or her on campus. And when we provide this educational experience, three elements become important. One is the curriculum, second is the pedagogy, and third is the assessment. So through these content, teaching learning methods, and assessment strategies, we help the student to learn. And this, when these things are in alignment, when content, pedagogy, and assessment alignment, it results in quality of education. What is quality of education? Quality of education is nothing but the quality of student learning. And this student learning depends on educational experience that we create for him. And how these three key elements help him to gain mastery of the different outcomes that we set for him to achieve or attain. The first element is the curriculum. Okay. So here we are looking at whether these three elements are dynamically changing with time or not. If you look at the first element, that is curriculum, yes, more or less it is dynamically changing every year in the university or autonomous colleges. The board of studies meet, and during the board of studies, there are industry experts, there are academicians from higher learning, institutes of higher learning. Then the subject experts all together, they discuss, they need what is not relevant, they remove what is relevant, they add. Either new subjects are added for the existing subject, new topics are added. So the curriculum is getting changed in a dynamic manner. So there is not much issue about the curriculum or the content. Then what about the second element, that is the pedagogy? When it comes to pedagogy or the teaching learning methods, it is not that dynamic. There are small changes are happening. There are at national level, at state level, certain workshops are being conducted to train the faculty members in active learning methods, in flipped classroom method, in problem-based learning. But still, there is a lot of efforts are required in order to train the large teaching community that exists in pedagogical methods. No doubt something is happening, but it is not sufficient. And the third is the element is the assessment. This is where it is a point of concern. Before this examination reform policy document came, absolutely there were no changes. Many of you may be 40 plus or 50 plus years. If you think of a question paper when you were a student, 3-4 decades back, at that time also, there were 8 questions and you are supposed to solve 5 questions. Or there will be 5 questions which are compulsory you have to solve. And the type of questions, whatever the pattern may be, the more or less they were same. They were only addressing the lower order thinking skill, or something like define this, explain this, describe this. Here and along with that, there will be 1 or 2 numerical problems or write some short notes like thing. The things have not changed much, even though now we have entered 21st century. Employees' expectations have changed, but our assessment strategies have not changed much. And when you look at the different educational experts or researchers, they say that very clearly content have very little impact on the student learning, and assessment has a profound impact on student learning. So keeping the content, if you change the assessment, it will have more impact rather than keeping the assessment same and keep changing the curriculum. So if you want to bring in any change in student learning, then you have to change the way the student is examined or how he is assessed. Therefore, realizing this, AICTE constituted a committee, as I said, to look into the examination reforms, and now it has come out as a policy document. Let us look at what the experts or researchers are saying. The first researcher whom I'm quoting is George Miller. According to him, assessment drives student learning. So if you want student to learn something, according to him, make it as a part of the assessment or the examination. The moment students come to know that it is important from examination point of view, then definitely will make a sincere effort in understanding it. Suppose if he is not able to learn on his own, he will go to his friend or friends, then from them he try to learn. So you make you as a teacher with some years experience, you'll be knowing that if you say in the classroom, this is very, very important from a examination point of view, every student start making a note of it. Okay. And if there are two teachers who are teaching two different courses for the same class, if some teachers, and let's say it is autonomous college, so that students know that ultimately the teacher who is teaching himself or herself is going to set the question paper. And if the teacher says that in my question paper, there will be more number of numerical problems. Out of 100, 60 to 70 marks will be for numerical problems. If they say, then students will start practicing solving more and more problems, which are discussed in the class or which are related to that subject, which are there in the textbook the teacher is referring, all that. If another teacher for the same batch of students, if he conveys that he's more interested in testing the concepts the student have learned, and then the derivation of the formula, working of the different equipment that he's teaching, then the focus of students with reference to that subject will be more of descriptive type of questions. So students are very careful. They try to find out from the old question paper as well as their senior students what type of questions will appear in the examination. Based on that, they start preparing for the exam. Therefore, if you want students to learn something, then make it a part of assessment. If you want your students to be good in communication, allocate marks for communication skills. If you want them to be good at project management and finance management, make project management and finance management as part of the assessment. If you want them to test for use of modern tools during the lab exam, make it a part of it and allocate marks for it. So when the students come to know that they are going to get assessed for it and they are going to earn marks for these different skills, then only they make an attempt to learn them. Let me quote another researcher, Ramsden. He says, assessment drives what students pay attention to and defines the actual curriculum. Okay. So in the beginning of a semester, heads of the department or head of the department do the subject allotment. As teachers, you'll get one or two subjects to teach and a lab or two to conduct. When the theory subject is allocated to you, you look at the content. Okay, there are 8 chapters are there. This is the textbook. These are the reference books. And that content of the subject becomes your curriculum. That is the curriculum of the teacher. And even if you go out to the class and share the same content with the students, that will not become his curriculum or the content. Again, he'll go to the library to find old question paper and talk to the seniors. He will ask for this subject what is important from subject exam point of view. Whatever the question paper or the seniors tell, that defines the actual curriculum for students. You all know it is our own experience. So therefore, the Ramsden what is said is very true. Assessment drives what students pay attention to and define the actual curriculum. It's what appears in the examination that is his actual curriculum, not what is shown as the syllabus of the subject. Therefore, when you talk about outcome-based education, when you talk about different outcomes, see that these outcomes find a place in the examination. Otherwise, students will not pay attention. The next education researcher, he tells the law of educational cause and effect states that it just sounds like a Newton's laws of motion. The law of educational cause and effect states that for every evaluative action, there is an equal or greater educational reaction. Okay. So depending on how the student is tested, his preparation also changes. Okay. Again, I used to quote a laboratory example. Let's say there is a third semester or fourth semester electrical engineering exams are going, lab exams are going on. Two exams are there. Same batch of students will attend one lab exam on one particular day and another on another day. And in India, we have a practice of inviting external examiners. And let's say in one lab subject, the external examiner tells that before allowing the students to go to the experiment table, you want to check the electric circuit. If it is correct, then only will allow. Otherwise, you is going to send them back, which is as good as their fail. In another, he will allow the students to conduct the exam. What he tells is, what is important, your pass or fail depends upon how you perform during the VIVOS exam. Okay. Now, because your evaluative action is different, in one circuit diagram, correctness of circuit diagram is important. In another, VIVOS performance is important. For one lab, students will practice more of circuit diagrams or correctness of write up what they're going to do in the first 30 minutes. In the second, they concentrate more on what questions the examiners were asking, and they start collecting the questions and preparing the answers. So this for every evaluated action, there is an equal or greater education reaction. If similarly, if we extend the logic, if students come to know that their communication skill, the project management, finance management, use of tools, ethical behavior, and their problem analysis skill, if these are going to be tested, then accordingly, the response will be they start mastering those skills or abilities. So therefore, we have to remember that for every evaluative action, there is an equal or greater education reaction. So if you want students to learn something, make it a part of assessment. And finally, this is the quote by Donald Melnick. He says, curriculum instructs teacher what to teach, and exam instructs student what to learn. More or less, they means the same. So as a teacher, for us, whatever the HOD gives the syllabus or the university prescribed syllabus, that becomes a curriculum to teach. But for students, even though we share the same syllabus, it is not the curriculum. Ultimately, what type of questions we come in the examination, that instructs student to learn. Therefore, there is a need for all of us to focus and understand what these program outcomes are, what these course outcomes are, and how my content of the subject is related to these program outcomes, and what type of assessment questions I should ask, so that at the end of 4 years, students will be good at all the 12 mandatory program outcomes and 2 to 4 program specific outcomes that you are going to define yourself at the department level. Okay. So keeping these things in mind, the examination reforms document has 3 key drivers. One is adaptation of outcome-based education framework, and second is growing concern about quality and employability of graduates, and third is the importance of higher order abilities and professional skills for employability of graduates. Let us look at the first one, adaptation of outcome-based education framework. See, what our employers or industry people are talking now, it started in the 80s in many of the Western countries. Industry people started commenting that graduates are not able to meet the requirements of the industry. Then a lot of discussions, deliberations at national level started happening in Western countries. Initially, they came out with the EC 2000. Then the same thing became another framework it took and became an outcome-based education framework. So here, at the very outset, the outcomes or expectations were made known to students as well as teachers. And keeping these outcomes in mind, program outcomes in mind, the content is designed. Since keeping the outcomes in mind, the content design is called as top-down design. And for each of the courses, course outcomes are defined. And then in order to show that through these course outcomes, program outcomes could be achieved, the CO-PO mapping is done. And then also the program articulation matrix, that is, one side you have a set of core courses, and then in the subsequent columns you have the program outcomes and program specific outcomes. Then the mapping is done, which course will support which program outcome, and we ensure that we have the subjects in order to meet the expectation of each of the program outcome or program specific outcomes. So through this exercise, we ensure that the content of a program will meet the requirement of all 12 mandatory outcomes as well as 2 to 4 program specific outcomes, which are written ourselves. So when this is done, then the quality of graduates improve, because these program outcomes are not defined by any department or anybody. These are defined by the professional societies in collaboration with the accrediting body of that country. Okay, in USA, it is American Society of Civil Engineers, Mechanical Engineers, Chemical Engineers, IEEE, like that. All these professional societies, along with accrediting agency like ABET, just like we have NBA in our country, they have ABET in their country. So they together, they have defined the program outcomes in their country. For international understanding, there is one more organization called Washington Accord. So if the members if countries become members of this Washington Accord, then they have to show the evidence that they have in their country also the programs are following these program outcomes or the graduate attributes, 12 mandatory, and the content is pedagogy are in line, so that at the end of 4 years, students are able to demonstrate the knowledge, skills, and attitude which are embedded in these program outcomes. Since expectations in the form of graduate attributes of program outcomes are at a global level, and if our content is meeting that requirement, and if we are using appropriate teaching learning methods to convey it to the students, and then you have appropriate, somebody is telling it is not audible. Is it so, or whether it is a problem with the individual? If my voice is audible, a couple of you can say yes in the chat window. Yeah, I think Lalita madam, you have to check at your level. Most of the people, it is audible. It may be local issue, internet issue you have to check. Thank you. So, since there is a content which can support this program outcome and teaching learning methods which are in alignment to take care of these program outcomes, and assessment strategies which are designed in such a way that we'll come to know whether students have mastered these program outcomes. So the quality of graduates will be definitely better than the countries where the traditional method is still in practice. So because of that, even when the Stanford Learning Assessment was done, the students of US, Russia, and China showed better performance compared to our graduates. Therefore, the AIC determined to bring in examination reforms. So one of the key driver is when other developed and developing countries have adopted outcome-based education and reaping the benefit of that and producing the better quality graduates who have edge over our graduates. So therefore, in order to remain competitive at global level, we don't have any other option than to adopt outcome-based education. Therefore, there is a thrust in our country to adopt outcome-based education. The second key driver behind these examination reforms is growing concern about the quality and employability of the graduates. Okay. The concerns are many of the employers of 21st century are telling the graduates, there are many jobs where graduates do not have the employability skills. They know, but they don't know, they have the knowledge, but they don't know how to apply that knowledge. That means they lack the skill and they lack the proper attitude. So they are good at defining something, explaining something, but using that knowledge, how to solve a problem in the industry, they don't know. He may be knowing, if you ask him what is arc welding, what is gas welding, what is brazing, what is soldering, he may explain. But you give a task, he don't know whether it should be welded or whether it should be brazed, what should be the amount of gas, the quantity of gas should be adjusted. Many things professionally what is required, those skills he is lacking, even though he is able to explain it. So therefore, what is happening is they have some technical knowledge, but they don't know how to apply it. In the competitive world, what is happening is the industry people or employers have to spend 6 months, 1 year in order to train the students so that they become productive members of the industry. During this time, they have to pay the salary, but they don't get much output from these graduates. So at the global level, the industries, our Indian industries lose the competitiveness because they are spending money on training. So that overhead will increase, the product cost will increase, and they are not able to sell in the global market. So in order to become competitive at global level, what they want is the student should be industry on day one itself with all the knowledge, skill, attitude, or at least within 1 or 2 months they should be able to learn and then become a productive members of the industry. So for that reason, they expressing the concern. Okay, they have when the technical interview they do well, but when we further dig into it, they lack the ability to apply that knowledge or come out with alternative solutions. Okay, and they are not aware about industrial practices, or they are not exposed to industrial practice. They have not seen. Therefore, AICT made internship mandatory. After first year, after second year, after third year, in fact, 8th semester completely you send them to industry. Let them learn how the industry works. Let them become exposed to industrial practices, what it means by teamwork, what it means by communicating with the seniors, communicating with the juniors in the industry. So they wanted to learn. Therefore, the second key driver is growing concern about the quality and employability of graduates. And third key driver is the importance of higher order abilities and professional skills for employability of graduates. Usually all over the world, in academic institutions, we focus on the lower order thinking skills. So if you look at Bloom's taxonomy level, there are 6 cognitive levels. Usually we attack the first 3, that is remember level, understand level, and apply level. They are first 3 levels. I request AICT host to make me panelist. There was an internet problem. Okay, thank you. Sorry for that disturbance. Momentarily, I was disconnected. Hope now it is audible and slide is visible. Some comments from, okay, thank you. Sridhar, Afsana, thank you very much. Jai Shri Madam. Okay, now we are talking about assessment strategy for outcome-based education. Well, we have the Board of Studies which will update the curriculum every year, and teacher on their own, they are learning some teaching learning methods. But what is important is whatever we are taught is learned by students or not. Therefore, we have to know more about assessment strategies. So if you look at the quality of education, there are three dimensions. But earlier people thought that if input to the system is good, the output will be good. Okay? If input is good, output is good. Therefore, even AICTE was insisting in the earlier system that staff student ratio should be this much, number of classrooms should be this, built up area should be this much. For every student, there should be 6 meter square area, instruction area. There should be 1 square meter of admin area, 2 meter square of amenities area, like that, and 30% of this combined should be circulation area. So they are focusing more on input. So many titles of books should be there, so many volumes should be there, and they thought that if input to the system is good, output is good. Therefore, they're focusing more on resources and infrastructure and finance. They used to sell that at least some 60% of the revenue collected should be spent on teacher salaries. If all these are meeting, then output will be good. So even though many institutions follow this, still the outcome was not good. Then they started adding another dimension. So it is not just input to the system is sufficient. You should, the process used to organize, control, deliver education, processes within the system or what happens within the system is also important. So apart from this dimension is also important. That is the time when in industry, the ISO certification become very, very important. If you want to export to European countries or Western countries, the ISO certification is must. What is ISO certification? It focuses on documentation. So for every process, there will be standard operating procedures. So what they used to say that if processes are good, the output will be good. For that, they used to give the example of that pressure cooker. If all of you participants, whatever the number of participants you have, if you are given an open vessel and a rice to cook, and depending on your expertise, some may be excellent rice, some may not be able to. So poor in quality, you cannot eat it at all. The cooked rice will not be uh, of that standard where you can eat it. But instead of that, if everyone is given a same brand of pressure cooker and a set of procedures for 1 bowl of rice, 2 bowl of water, then you have to put it in a pressure cooker, close it, then heat it till 3 whistles are given. After that, put in a sim mode. After so much of minutes, you switch off. Then more or less within a small tolerance, depending on how careful you are in measuring the quantity of water. Okay, the quality will be of at least eatable quality. There will not be too much variation. So that's what they were talking. Even in institution, the process should become person independent. The process should be strong. So if input is good, if process are good, output will be good. Even after this also, even many institutions went for ISO certification, but even then, their graduate quality was not fully acceptable by the industry. Then they said it is not input or process, the output is also important. We should also measure the output, quality of the output. Proof of the pudding is in eating. That kind of a thought process started. Initially, they started talking about the output. The output of system, then the people started output will be always in quantity basis. So we should talk about in terms of quality. So what initially started the output suddenly became, slowly it took the shape of outcomes. So outcomes refers to the quality. Quality of graduates in terms of their ability to apply knowledge of science, mathematics, engineering in solving complex engineering problem, in analyzing complex engineering problem, in developing solution for complex engineering problem, in investigating complex engineering problem, in using modern tools, both hardware and software tools, in their ability to understand the role of engineers in society. Then, what is the impact of engineering solutions on environment and sustainability? About the ethics, about the communication skill, about the teamwork, leadership, project management, finance management, and about lifelong learning. All these things become important. They started focusing on outcomes. So the earlier in traditional method, the focus was an input, and of late, the increasing emphasis is on the output as well as the outcomes, that is, graduate outcomes have become very, very important. So, in order to ensure that our graduates have the abilities to demonstrate in all the program outcomes which are mandatory, then what is important is all the technical institutions in India must adopt outcome-based educational framework. There are 4 stages when you implement OBE. The first stage, you have to formulate program educational objectives, also known as PEOs, and next is program outcomes, which are known as POs. In other countries, they don't talk about PSOs, but in our country, along with POs, they also, NBA insists on PSOs, that is program specific outcomes, which are defined by the concerned program or the department. So when you define POs and POs, that bring clarity of focus. Okay, at the end of 4 years, our students have to demonstrate this knowledge, skill, and attitude that is conveyed by POs, and what our alumni within 3 to 5 years have to achieve within 3 to 5 years of their graduation that are expressed by POs. So keeping these in mind, the OB implement process starts. Then we have to come out with the content and show that our content support these POs. Therefore, NBA insists for mapping of outcomes through curriculum, which is known as program articulation matrix. In the first column, we make a list of subjects that we teach, and the next 12 to 16 column, we write the program outcomes as well as program specific outcomes and show that there is a subject or a lab or a project, something or experience, field work or internship experience, final project experience, which could be mapped with the different program outcomes or program specific outcomes. Then, having done that, having ensured that we have content to support the outcomes, the next step in OB is to design and deliver aligned teaching learning activities. Because in the very first slide of my presentation, I showed you student learns through educational experience that we create. And these educational experience we create through different teaching learning activities. So these teaching learning activities are appropriate for different program outcomes. You cannot use only one type of teaching learning activity to train the students in all the program outcomes. Let's say you are using chalk and talk. That is also a method of teaching learning. The chalk and talk doesn't help the student to gain mastery in communication skill. For student to become good at communication, oral communication, written communication, you have to give that opportunity for him when you are spending 4 years with you. For oral communication, you have to give him an opportunity to give a seminar or a presentation. Or if he has to demonstrate written communication, you have to ask him to write journals, lab journals, or project reports according to a particular format. So teaching learning activities changes as the program outcome changes. Similarly, for teamwork, you cannot teach by chalk and talk or using PPT mode of teaching. You have to form the groups of students and allow them to work. Then you have to tell what the team dynamics means, or how the roles are defined for each of the team member, how they should come together, meet, how meeting, how discussion should happen, how the minutes should be recorded, and what are the expectations for the plan for next week, and all those things. Only by doing students learn about teamwork. It's not just by a teacher giving a lecture on what teamwork means. Student will not learn. So appropriate teaching learning activities have to be designed in order to train our students in different program outcomes and program specific outcomes. Once that happens, then the last stage comes. Whatever you are taught, whether students have mastered or not, or attained or not, to know that we have to go for assessing attainment of outcomes. This is the steps. So exam reform document focuses on this. The first three steps are becomes a part of OBE workshop, which is not this one. So the fourth one, assessing attainment of outcomes, is part of this workshop. Just to maintain the continuity, let's start about OBE framework. In OBE framework, these program outcomes, which are defined by the professional societies in collaboration with the accrediting agency, like this ABET in US or NBA in India, like that, they provide clarity of focus. Okay, these program outcomes are nothing but the student capability at the end of graduation. At the end of 4 years, what knowledge, skills, and attitude students demonstrate, they are known as program outcomes. Keeping these program outcomes in mind, the program design happens. What we mean by program design, identifying the content, identifying the appropriate teaching learning methods, and identifying appropriate assessment strategies. So this is known as program design, and it is top-down in approach because we start with program outcomes. So content means the various things we have to teach in different courses. From first semester to eighth semester, we have n number of courses. It could be 30, 35, 40, depending on the different universities. So many courses we teach. And for each course, we write course outcomes. That is, we write at the end of the course, student will be able to, then it is either is able to analyze something, apply something, design something, okay, write a project report, something like that. We define these course outcomes. Then we say these course outcomes collectively help us to achieve the program outcomes. Okay, program outcomes are common, they're generic in nature, whether it's civil engineering, mechanical engineering, E&C, electrical engineering, or computer science, biotechnology, chemical engineering, whatever undergraduate engineering program is there, these program outcomes are common and they are very generic in nature. But subjects are different. So therefore, we have to ensure that through course outcomes, we have to show the attainment of program outcomes. Then the question comes assessment. The program design is top-down approach, where assessment is always bottom-up approach. Because first you have to deliver the course, then only you can assess. So before examining a student, you have to teach. Therefore, assessment is bottom-up approach. So what mistake that was happening earlier, even though from 2011, NBA started uh, assessing the programs based on outcome-based approach, many institutions started practicing well-being. But there was a mistake the most of the institutions they're doing, that is in connecting the course outcomes with the program. As I said, program outcomes are generic, very high level. They're common to all types of undergraduate programs. But courses are very specific to that program. The course of civil engineering are entirely different from course of computer science. And they are different from mechanical engineering. Then how you connect these course outcomes with program outcome directly? So this was the missing connect. What people were doing was they were writing program outcomes, they were writing course outcomes, they are mapping course outcomes with program or COPO mapping. They are doing the keeping the course file. Then they were going to the classroom and continue to teach the way they were teaching earlier. So in this way, the OB framework was existing course file. There was not much change was happening in the way they were teaching. And question paper also used to be the same what they were there three decades back. So this was the missing connect. Even though we are saying we have implemented OBE, it was only up to writing PO, CO, COPO mapping. And based on the Marks scored by students, some attainment were calculated showing the target and threshold method, but entire exercise futile because you're not meeting the connecting the course outcome in the program outcome was not correct. That will be explained in this workshop. Today I will explain a little bit, but tomorrow in the second session, more clarity will be given about connecting the course outcome with graduate attributes. So these are, since it is a overview session, I am not going to go in detail about these graduate attributes. There are 12 graduate attributes which are accepted by Washington Accord, and any country which want to become member of Washington Accord, they have to show that they have implemented OB in their country and the student demonstrate the attainment of these outcomes. Okay? So one is engineering knowledge, second is problem analysis, third is design and development of solution, fourth is conduct investigation of complex problems, fifth is modern tool usage, sixth is engineer and society, seventh is environment and sustainability, eighth is ethics, ninth is individual and teamwork, 10th is communication, project management finance, and last 12th thing is lifelong learning. Second session today is all about the graduate attributes of program outcomes. So there I will explain in detail. So these program outcomes give us the clarity of focus. So the problem is when the colleges started implementing OB in their institution, the faculty faced with these doubts. What are the expectations of program outcomes for the student to learn and attain? And how my course means subject in this. Program means discipline of engineering. Civil engineering is the one program, mechanical engineering another program, like that. Course means subject. Signals and system is one course. Software engineering another course. Thermodynamics another course. So course means subject. So teacher were confused about these things. What are the expectation of program outcomes for the student to learn and attain? And how my subject of the course outcomes are connecting to these expectations? Many times even HODs are not very clear about these things. So when the teacher raised this question, they are not able to clarify the doubts. So something people are doing, whatever they understand. Because of this lack of clarity at individual level and system level, individual means faculty, the individual faculty, system level, the entire institution itself, engineering college itself, at a system level, there was no clarity. Because of that, the implementation OB had become a challenge in our country. Then if you want to implement it properly or adopt OB framework, first you have to become familiar with program outcomes, what they are, course outcomes, then topic outcomes. Okay. Then, as earlier said, design is top-down approach. And if our students have to demonstrate the attainment of program outcomes, that depends upon how well they show the attainment in course outcomes or topic outcomes. Because for program outcomes demonstration, attainment of program outcomes is shown through attainment of course outcomes. And course outcomes is through topic outcomes. Some institution we do, but some of the institution they stop only at course outcome. That is also accepted. NB accepts. If you are interested, you can go up to course outcomes. Otherwise, you can stop at course level itself. Okay. So through course outcomes, you can show the attainment of program outcomes. So how well the program outcomes are attained depends upon how well course outcomes are attained or how well course and topic level outcomes are attained. It depends upon to what level your institution decide to write the outcomes. Okay. So therefore, the course assessment becomes important because the program outcomes attainment depends on course assessment or attainment of course outcomes, and attainment of course outcome depends upon course assessment. How well you are trained to connect your assessment questions in your subject with the course outcome becomes important. If you are connecting your subject questions either in internal assessment or take home assignment or course project or semester exam, if that connection with the course outcomes are correct, then only the attainment of course outcomes is correct. Then through this you are showing the attainment of program outcome, then that will be correct. So if you fail at this stage itself in connecting the assessment question of your subject with the course outcome, if that is not correct, then course assessment fails, then that results in unrealistic program assessment. If it is correct, then that is also correct. Therefore, the missing connect is this one. So first, as the faculty members, all of us have to learn how to connect the questions that we ask in our subject with the course outcomes. If that is correct, then program assessment will be realistic. Then implementation of OB will be effective in our institution. So this is very, very important, how we connect assessment questions with the course outcomes. And this is the objective of this workshop, to train you in that itself. Therefore, at present, the weakest link in adopting outcome-based education framework in our country is realistic measurement of attainment of outcomes. We are measuring, but they are not realistic because we lack how to connect the course outcomes with the program outcomes. We are showing some mapping, but that is not correct, which you will realize by end of tomorrow's second session. Today also you will learn something, but tomorrow you will develop better clarity. Therefore, as a teacher, you have to understand how to make realistic measurement at course level and hence at program level. In order to bring this clarity and to overcome the challenges in connecting POs to assessment, the policy document has given some suggestion. They say the program outcomes represent fairly high level generic goals that are not directly measurable. In management terminology, you can say these program outcomes are 50,000 feet. Just to get the feel, they are at 50,000 feet above the ground. Let's see what it means. When you look from very high height on the ground, whether their house is there or road is there, somebody standing, some cars, motorcycle, whatever there, they will not be very clear. Okay, because you are at a very high level, the things will not be clear. In that sense, program outcomes are at very high level, so you do not have that clarity. Therefore, a realistic observability and measurability of the POs at course level is very difficult. Since program outcomes are high level generic means they are common to all undergraduate engineering programs, and it is not possible to measure them directly. It can be measured only through indirect means, that first you measure course outcomes, then you show the attainment of program outcomes. Therefore, measurement of attainment of course outcomes become very, very important. So measurement at course level becomes important, and for that course assessment becomes important. So for that reason, this document has brought more clarity and specificity to program outcomes. They started explaining what these program outcomes are, so that everybody involved in this teaching learning process will develop better clarity about the program outcomes. And in order to help you to assess correctly, they propose two-step process. So to enhance resolution of POs, they said in the first step, you have to identify for each of the program outcomes competencies. What are the abilities embedded in each of the program outcomes, which are also known as competencies? First, you make a list of these competencies for each of the program outcomes. Earlier, I said the 12 program outcomes. For each program outcome, you identify the competencies. Then that's the first level. Second level is for each of the competency, identify the performance indicators. So when you have at 50,000 feet program outcomes. When you define competencies, now we are at 25,000 feet. Now you have come down nearer to the ground, things start looking more clearer. And for each of the program, the competency define performance indicator. Performance indicator will be at a ground level. So now you have very, very clear view of what you are assessing. Okay. So rather than connecting your question directly with the program outcomes which are at 50,000 feet, connect them with the performance indicator which are at a ground level. Your questions are ground level, performance indicator ground level. Then through performance indicator, you connect to the competency which is at 25,000 feet. Through competency, you connect to the program outcome which is at 50,000 feet. When you do this, then you will come to know, okay, my question is not addressing the entire program outcome. It is only addressing a part of program outcome. Then I have to ask some other questions in either this course or some other course, so that other performance indicator related to different competency of that program outcomes I should ask. Then only I am training my students in the entire program outcome. So later it becomes clear when I explain you. So this two-step method is the heart of this policy document. You must understand this in order to implement this policy document effectively at your institutions. Okay. Let us try to understand a little more about this competency. Every program outcome implies different abilities to be attained by the learner. Learner means a student. Okay. Let's take, for example, PO3, program outcome 3. It talks about design and development of solutions. That is, design solutions for complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for public health and safety and cultural, societal, and environmental considerations. So if you look at this, so it is a very lengthy statement. Many times, many faculty members, there will be some exception, they can read and understand, but many staff members have difficulty in understanding what are the expectations of this program outcome itself. Here you can see it refers to design solution for complex engineering problems. Many times faculty members will not be knowing the definition of complex engineering problem. When you don't know the definition of complex engineering problem, how are you going to pose a design problem which is complex in nature, and how you are going to train the students in designing solution for complex engineering problem. Therefore, first as a teacher, we have to become familiar with definition of complex engineering problem as well as the expectation of this program outcomes. Okay, if a student has to come out with solutions for a complex engineering problem, first he should have the ability to define a complex open-ended problem in engineering terms. Let's say a mechanical student is taken to a industry where there is a furnace, and the person who is telling that here this is a type of furnace, actually the surface temperature of this furnace should be less than 60 degree, but if you see, he can show you now it is 75 or 80 degrees centigrade. Now, since you are engineering mechanical students, I want to come out with a solution wherein you have to design solution such that its temperature becomes less than 60 degree. So here there is no textbook. There is a furnace in front of the students. They are seeing it. They can get little more details about the furnace, what type of bricks are used, what type of material is used for plastering, and all those things they can get, its dimensions. Okay, but they have to define the problem themselves. If they do not have the ability to define a problem, then there is a question of coming out solutions. The first step is to define a complex engineering problem. That ability the student should have. Once he is able to define the problem, then he should generate a diverse set of alternative designs. Because In real world problems, always there will be a set of alternate solutions. If you use a particular material, the thickness of insulation will be less. If you use another material which is cheaper in quality, thickness of insulation will increase, weight will increase. So depending on the type of material used, the thickness varies, the cost varies, the solution varies. So he should be able to come out with a different solution. One is low cost, medium cost, high cost, whatever, depending on the client's need. Therefore, he should have the ability to come out different set of alternative design solution. That is the second ability required for this PU. Then the third ability, once you come out with different set of solutions, then going through this alternative set of solutions, he should be able to select the optimal design or the best solution for further development. So you have to train him in use of a tool like pug evaluation chart or morphological chart through which he is able to select the optimal design solution or scheme. That is the third ability. The fourth ability is you should have the ability to advance an engineering design to define end state. Here end state is the surface temperature should be less than 60 degrees centigrade. You should be able to design a solution which will ensure that once implemented, the temperature, surface temperature of the furnace will be less than 60 degrees. So only when he is able to demonstrate these abilities, then only we can say that he has mastered the competency or master the competency show the attainment of PO3. Therefore, we call these abilities as competencies. If you read only this statement, PO3, it is difficult to understand. When the same thing are expressed in terms of abilities or competency, now it becomes more clear to them, clear to teacher as a student. Oh, then teacher come to know I have to train my student in defining a problem statement, in helping him to generate diverse set of alternatives or solutions, in selecting the best one, and finally implementing and coming out with a solution. And it is the input for student as well. Okay, if I want to earn more marks, then I should learn all these competence because they will be part of assessment or examination. So when teacher is going to examine me, he is going to test me for these competencies. Now comes design of question paper. Your question paper, or at least in rubric-based assessment, they should have the question related to this. When students come to know that, he will be tested for defining a problem statement and coming out with alternate solutions, then selecting one and implementing it. Then he will start practicing this. Then he will show the demonstration of PO3. So if you are very clear of all the program outcomes, their associate competencies and performance indicator, then there is a clarity for you, there is a clarity for student. Then, as we said earlier, assessment drives student learning. Since student come to know that he will be tested for these competencies, he start learning, it will all become part of the curriculum. Either he learn in the classroom or through his friends or through somebody or asking questions in the internet, downloading or watching YouTube. He will learn and then earn the marks. That is how outcome-based education help solving problem with connecting to the network. Is it with the individual or others also? Okay, now I have connected with another network. Now are you able to hear me? Okay, thank you. Okay, thank you, Vikas, Dr. Charda ma'am. Thank you. So now this is the explanation for competency. So if you simply read, any teacher or student read this complicated statement, they will not understand what is the expectation of this PO. Therefore, this exam reform policy document says, first, competencies associated with these program outcome. You need not have to do anything. Already they are defined for each of the 12 program outcomes. They are already available in the policy document. Only you have to read and understand them. Okay. So once you understand these competencies, the next step is defining the performance indicators. What are these performance indicators? They are explicit statements of expectation of the student learning for each competency defined. As I said earlier, POs at 50,000 feet, competency at 25,000 feet, and PIs at ground level. Now you have a very beautiful view about the expectations. No confusion at all or no ambiguity at all. So these performance indicator, they act as measuring tools in assessment to understand the extent of attainment of outcomes. So earlier what you are doing, you are connecting the question with the COs. Now what this method says, first connect the question with the PIs, performance indicator. Again, you don't have to worry. These PIs are for each of the competencies are already defined. They are available in the policy document. So you don't have to start worrying, okay, how to define PIs for each of the competency. So for all the program outcomes, competencies and PIs are already defined. Only you should learn how to use them. Okay. So once you learn, these PIs will become the measuring tools in assessment. Let us understand, in the previous example, PO3, we wrote 4 competency. In the second competency was about ability to generate a diverse set of alternative design solutions. For that, what PI write? One is apply formal idea generation tools to develop multiple engineering design solutions. Usually we, in our institute, we write what is known as PUG evaluation chart, PUGH, PUG evaluation chart. Okay. On different criteria, they give weightages. It could be for the simplicity of design or the ease of manufacturing or fabrication or a cost or about the sustainability, impact on environment, like that. They take different criteria and give weightages, and for some marks, fixed marks, they give the marks, and one which gives maximizes depending on that, they select. Okay, so you should first, as a teacher, you should teach the idea generation tool. Then students should be familiar with the identify the functional and non-functional criteria for evaluation of alternative design solutions. First, you have to teach him how to generate, also help him to identify these functional non-functional criteria. So once that is done, then he is, if he is good in these two, then he is good in this competency. Like that, if he is good in all the performance indicators of 4 competence related to PO3, then he is good at PO3. That is the understanding. Otherwise, there is a gap which you have to address in after every semester. Okay, this is the gap you have to address either through changing the content or changing the teaching learning method or through appropriately adopting the assessment strategy. So once you use two-step method, as I said, in the second session as well as tomorrow second session, I will going to explain this two-step method in detail. So it is the overview session. I will just mention and leave it. So once you use two-step method, that is defining competency for each of the PO and defining PI for each of the competency, it brings a clear understanding of the expectation of each program outcomes to faculty and students. Then connecting course outcomes to performance indicator and hence to POs will be easy and accurate. So here you can see you have course outcomes. Earlier the PI was missing. The questions used to come. So once you start implementing this exam policy document, once you write course outcome, write PI. Then connect this PI with the examination question. This is a change because PI is at ground level, question is also subject question is at ground level. Connecting this is correct. When questions are connected to PI, PI is connected to course outcome. Then anywhere through CO PO mapping, you are connecting CO to PO. So by introduction of PI, you will come to know whether the PO is attained fully or partially. If all the PIs, let's say, if there are 8 PIs associated with program outcome 3, only when all the 8 PIs are attained, then only PO3 is attained. Otherwise, if you take out this PI, you ask some question related to some CO, and CO is connected to PO, then you'll say that PO3 is attained. You don't know whether it is attained fully or partially because neither you have defined competency nor you have defined PIs. So every time, every question if is connected to PO3, you used to say PO3 is attained, which is not correct. Okay, the student might have demonstrated only the ability to formulate a problem and coming out with few solutions, but he don't know how to select the best and how to come out with the actual solution. But just because he is doing something, you are showing the PO3 is attained. So by use of two-step process, you'll come to know to what extent he is comfortable in showing the attainment of particular PO. Okay. So by mapping examination questions with performance indicators, we get clarity and better resolution of the assessment of COs and POs. Having understood that, the next issue they have tackled in this examination from policy document is improving the structure and quality of assessment. Structure means the alignment between the content and the CO and the questions. And quality refers to the Bloom's taxonomy level which the question is designed. Okay. So a few decades back, if you ask who is a good engineer, then the answer would have been the one with good technical capability. Okay. That is when we graduated in the 80s. Who is a good engineer? If you know technically good, you are a good engineer. But in 21st century, employers' expectations have changed. In fact, they are growing day by day. Along with technical capability, they want leadership skills, teamwork skills, problem-solving skills, critical thinking skills, lifelong learning skills, ethics and social responsibility, communication skills, and many more. As I said, project management, finance management, all those things. So when these expectations are growing, and again go back to the first 4 quotes which I have presented to you, assessment drives student learning. Okay, curriculum instruct what teacher what to teach, exam instruct what student to learn. In this context, unless assessments, these qualities or questions related to these abilities or competencies are part of our examination system, they will not become part of the curriculum, not will make an attempt to learn, and you will not gain the mastery over these things. If our students have to be good in all these things, then we should test him in our internal assessment test or semester exam or in projects, field work or internship. Then only he will pay attention to it and he will make an attempt to learn it. So these are the 12 outcomes mandatory for all undergraduate engineering programs in India. First 5 we call the technical outcomes. Next 7 we call them professional outcomes. Okay. These are professional. If you ask many of the colleges, say that okay, we are doing quite good when it comes to technical outcomes. Only recently we have started focusing on professional outcomes. And even when you look at the definition of these technical outcomes, everywhere it comes complex. Student in first one, students should have the ability at the end of the program. Students should have the ability to apply knowledge of mathematics, science, engineering fundamentals to solve complex engineering problems. And here they should have ability to analyze complex engineering problems. They should have ability to design solution for complex engineering problems. They should have ability to investigate complex engineering problems. They should have the ability to model complex engineering problems. So when these complex engineering problems can be solved only when students are trained in higher order abilities. What are these higher order abilities? Higher order abilities means analyzing, evaluating, and creating. Only when you train the student, they will have develop the ability to solve complex engineering problem or analyze complex engineering problem, all these things. So even though when we say we are training students in technical outcomes, it is not to the full extent. The present exam system, in our system, memorization occupies the dominant role. You also know that students by heart the answers they write, whether they understood or not, they can, because the content is same, looking at 3-4 years question paper, they can think what type of questions will come, and they will by heart, and if it comes, they simply write the answer without knowing without understanding the concept clearly. But as per exam system, if you write correctly, then teacher has to give the marks. We are not telling that memorization is bad. No doubt the recall of factual knowledge is essential. But every time if 2 into 2, he not how to use calculator. 2 into 2, 4, he should know. Or some of the knowledge, what is Kirchhoff law, what is Newton's laws of motion, some things, whether it's a good conductor or a bad conductor, these things should be known. These things should be known. Otherwise, it is very difficult to process. Otherwise, it take a lot of time to solve the problems. So, memorize some amount of factual knowledge is essential, but that is necessary but not sufficient. Other abilities like analysis of problem, solution of complex solving solution complex any problem, investigations, application of uh, these modern tools to analyze or simulate, all these are essential. So which cannot be done only through memorization. So for that, we should have to use different teaching learning methods, assessment methods. So our assessment process must also test higher level abilities like ability to apply knowledge, solve complex problems, analyze complex problems, synthesize and design problems. Now the question comes, how will we ensure it? Okay. So for that, this policy document suggests revised Bloom's taxonomy. Since tomorrow you have a complete session on Bloom's taxonomy, I am not going to get into details of it. Only I will say that there are 6 levels, and first 3 are lower order thinking skills, and next 3 are higher order thinking skills. So by making use of these Bloom's taxonomy level, you can design questions related to higher order thinking skills. When you set a questions, they should have something to analyze, something to evaluate, something to create. Then only you can claim that you are training students in solving problems which address higher order abilities. Then once you know that these 6 levels are there, lower level remembering to highest level creating, what are the appropriate methods to test them? Whether all to be tested in internal assessment test and semester exam, or which we call written examination, or which also we call fixed hour examination, or different methods should be used for different levels. For remember type of questions that define Newton's law, define thermodynamics law, define Kirchhoff law, sketch and name the parts, such type of questions. Understand, explain the working of a machine, lathe machine, drilling machine, or uh, give a numerical problem which is he's not familiar, where he applies the laws of a subject which you are taught to solve it. And to some extent, where a question involves some analysis, these can be tested in fixed hour examination, either internal assessment test or submission exam. But when it comes to higher order abilities, like analyzing, evaluating, creating, very small types of analyzing can be addressed in fixed hour exam. Therefore, analyzing falls in both the category, lower order as well as higher order. Okay, analyzing by classification, it is higher order thinking skill. So when your problems are addressing these three levels, don't test these levels in fixed hour exam. That is the main message this policy document is giving. If you want to test them in course project. Course means you are teaching a subject. In that, you are giving a small project wherein student will apply the concepts of that subject to do that project. Usually, when you ask student to do a course project, you in general, you will not ask him to come up with a physical artifact or a physical device because it could cost money. Okay, if every teacher are giving start course project, then it will be extra burden for the parents. So course project usually done in a simulation type of environments. Then mini project, minor project. Okay, they're still there higher level. Usually in our case, in fifth semester we give mini project, sixth semester we give minor project. In seventh semester, use senior design project, capstone project in the eighth semester, open-end problems we give in the laboratory. So these are the best methods to test higher order thinking skill that you must understand through this workshop. Don't write a question in a fixed hour exam and then write L5, L6. It's totally wrong. So these levels should not be tested in fixed hour examination. They need lot of iterative. They are iterative. The solutions are open-ended. They need understanding need of the customer. They need coming out with alternative solution, selecting the best one, then coming out with the final solution. So much time will not be there in a fixed hour exam. Usually internal assessment test will be of 75 minutes. Final exam will be in general either 2.5 or 3 hours. Within that time, these higher order thinking skills cannot be tested. Therefore, they should be tested through this. So if you understand this, there is a great learning of this workshop. Okay. These lower order thinking skills, test them in fixed hour exam. Higher order thinking skills, you test them in these. Okay. The third issue, which this policy document deals with, is assessing higher order abilities and professional skills. These are the higher order abilities already I've talked, analyzing, evaluating, and creating. And these could be tested by use of Bloom's taxonomy. So use Bloom's taxonomy to design a question paper which will test the higher order abilities. That is the message from this slide. Then what are the challenges? The main obstacle in addressing these outcomes is the limitation of educational experience we create within our engineering programs. Again, I go back to the first slide. I showed student learning, and then I said students learn through the educational experience that we create. So unless in the classroom, in the laboratory, in the field, if we are not creating that educational experience, which will train our students in analyzing, evaluating, and creating, then how students will master these abilities? And therefore, we say that most of our coursework in our program, that most subject what we deal, we teach technical knowledge and skills in a typical classroom setting or laboratory setting. And in a classroom or laboratory, we usually deals with 3 Bloom's level, that is remember, understand, and apply. And again, these are related with solution of textbook problems. And one of the attribute of complex engineering problem is they are not a problem which are found at the end of the textbook. So any problem which appears at the end of the textbook is not a complex engineering problem at all. It may be a difficult problem, but it is not a complex engineering problem. Complex engineering problem means it should not appear in the end of the textbook chapter. It should not be completely defined. It should be ill-defined. Only when a student assumes something or makes some choices, then only statement is complete. Or when solving this problem, you have to make use of some physical laws or computational methods or numerical methods, then only it is a complex engineering problem. Well, if it is not satisfying these three criteria attributes, it is not called as complex problem. Okay. Then the higher level abilities are difficult to assess through our conventional exam system. Conventional exam system, whether internal assessment or semester exam system, they are not good opportunity to test higher level abilities. Therefore, you have to go back again to these methods only. Course project, mini project, minor project, capstone project, open-ended. Okay. Again, these I said the first 5 technical skills and 6 to 12, 7 outcomes are professional skills. And 21st century employers, they are also interested in professional skills. So only when you train students in professional skills, they become employable. Right now, they are not employable because first they lack their higher order abilities like analyzing, evaluating, and creating, because we are training only in the lower order thinking skills. And second main reason why they are not employable is they lack professional skills. Because most of the time we are engaging students in the classroom. And it's very clearly written here, acquiring a professional skill may not result simply from participation in a particular class or set curriculum. Even a student is appearing all the 40 classes or 50 classes allocated for the subject, even at 100% attendance, he cannot learn these things because these professional skills cannot be acquired by sitting in the classroom. How a student will become good in teamwork if he is sitting in the classroom? He has to work in team, then only he will become. How will good in communication? Only when he is only listening to what teacher is talking. Okay, how will he be good in ethics when he only listen to the lecture? How will you become good in project management when he's only listening to lecture about what is project management, what is finance management? Therefore, these professional skills needs different pedagogical methods or teaching learning methods. And when it is not possible to teach them in the classroom, they can also be cannot be tested in conventional exam system. So these skills need to be assessed in a different way. Therefore, for that you have to understand what rubrics are. So they need what is known as rubric-based assessment. Only through rubric-based assessment, these professional skills can be tested. And once you prepare a rubric, they should be shared in the beginning of the semester itself. Student should know for what he is going to be tested. Okay. In the second session, I will taking the example of communication. I will explain you. Then, to address these challenges, that is training of the students in higher order abilities as well as professional skills, comprehensive reforms are needed in the way we design our curriculum, student learning experiences that we create, and assessment of the outcomes. Okay. So therefore, reforms in educational experience, be it curriculum, pedagogy, and assessment, which are responsible for student learning. Okay. For that, you have to move towards experiential learning rather than talking, give more opportunity for the student to learn through experience, through exploration. Okay, that is what problem-based learning or fifth classroom methods expose them, or give more and more weightage to course projects, mini projects, minor project like that. Earlier, our students were doing only one final year project 10 years back. Later on, we introduced two projects in first year itself. Another few course project in second year. Fifth semester mini project, sixth semester minor project, senior design project, final year project, or capstone project like that. So we started increasing the weightage for experiential learning component. Then we started contextual learning. Contextual learning means Hubli is known for valve industry. The valves which are used for controlling the flow of fluid, be it water, be it liquid, or crude oil, or gas, or any of the fluid control valves. Hubli, that is, this city is known for. Then, while teaching the material science, manufacturing process, design, this walls is kept at the center, and teachers started connecting with it. When he's talking about material science, what are material are used in walls for different components of the walls. When manufacturing, what manufacturing methods are used in manufacturing wall. So when the context is created and students are taken, there are many wall industries here. When they're taken and shown, students see, come back, they relate what they're learning with what they have seen in the industry. So contextual, make the teaching learning contextual, then situated learning. So take them to the field, give the opportunity for internship. So through that, during that period only, you can test them for their communication skill, for their leadership skill, for their ethical behavior, punctuality, all those things can be tested for situated environment. So therefore, our way of curriculum design, teaching learning experience assessment should change. Only then, when that happens, then student learning will definitely be improved. So again, a repetition here, few education experience which can make the students good in higher order abilities and professional outcomes are this. Already they are shared. Course project, open and experiment, project-based learning, MOOC courses. MOOC courses test him for lifelong learning, whether he can learn on his own. Okay. Co-curricular experiences. Okay. Then mini and minor project, co-curricular experience, use teamwork skills, ethical behavior, all those can be tested. Then final year projects, internship experience, e-portfolio of students. So these experiences need very different tools for assessing students' learning. Okay. Then the questions that come to our mind is, can our student handle this? You may feel that, okay, now you are talking about 12 program outcomes which are mandatory, 2 to 4 program specific outcomes. Can our student handle this? Can our students equip themselves with higher order level abilities like analyzing, evaluating, creating, and professional skills? 7 professional skills that are listed. As it is, their performance are low in the examination. Okay, we have been practicing this from 2008. Okay, now 13, almost more than 12 years are over. With our experience, we are telling it is not the problem with the students. They will just raise to the level we set for them. Okay, you set the level, they get prepared. That's what assessment drives student learning. Once the student come to know that they will be tested for this, they raise the bar, they learn it. Only thing is you have to make it very clear in the beginning of semester for what level they are going to be tested. So we have to set the standard which today's world and employers need. What is the use of producing students who lack these higher ability and professional skills? You may churn out more numbers which are not employable rather than equip them and make them more employable. It's good for students' career, it is good for industry also, and it is good for the country. Country will become more competitive internationally. And to do this, as an individual teacher, you cannot bring these educational reforms. It is a systemic reform. Everyone who is involved, be it a regulatory authority like AICTE, be it a TechUp institution, we are also using there for NPR, National Project Implement Unit, review, right? Be it university have to drive, or be it institutions, the institution for all the programs. So all are involved, regulatory authority, universities, institutions, teachers. When all are involved, then only the systemic reforms is possible. Okay. Then there are few action items for the different groups. Since you are all faculty members, only I will address the faculty things. What are few action items for you people after the workshop? Based on the input from this workshop, have a relook at the structure and quality of assessment for the course you are teaching. What type of questions you are asking, and what PIs it is addressing, and what COs are addressing, how your COs are mapping with the POs, and at what Bloom's level your questions are there. That you check. Then come up with new question paper that are in line with reform report. If old question paper is not of that quality, now after this workshop with the learning that is happening, try to design a new question paper, model, call it the model question paper, so that you address lower order thinking skill as well higher order thinking skills appropriately. Then share that question paper with the AICTE, and if it's good, they will display on their website. Okay, because they are creating. If it is the entire question paper is not good, they select the good questions and add them to the question bank that creating. Most important is also think about the new educational experiences you need to bring into your course or subject to create opportunity for embedding higher order skills and professional skills and experiment them in your next delivery. Because I've said students learn only through the educational experience what that you create. So the responsibility comes on you. If you want to make your students good at applying the knowledge, you have to create that experience. If they're good in analyzing the problem, you have to give that opportunity for him to analyze. That means you have to take home assignments you have to give where you define a scenario based question. He will read himself, understand what is expected from it, then analyze, then come out with a solution plan. So if you do not give that opportunity, how you expect he will become good in problem analysis? So this type of designing of education experience is the major task. Immediately may not be possible. You learn this semester and next semester you practice it. For institutions, just you read them because that is individually cannot do much. Just have a look at them. So use of IT is very implement, very essential because teachers' time should not be wasted in calculating the course outcomes, attainment, program attainment. There should be a softwares are available. Only teachers should correct the answer book, feed the marks into that software. Rest of the things should be done by the software itself. Then it becomes teacher can use his time for his knowledge updation as well as doing research rather than spending time in calculation of CO attainment and PO attainment. What university should do, they should focus on board of studies and board of examiners. They should train them. They should come up with their own university document. I know the names, but I cannot tell because it becomes advertisement. Uh, if you simply Google it, you will find. I should have taken the name, but otherwise somebody may uh, point finger at me that I'm using this workshop to promote somebody, even though I don't have any understanding with them, but I don't want to name. So enhance experiential learning experience. Weightage for, as we said earlier, only our students are doing final project. Then we introduce project at first year level, second year level, then third year mini project, minor project, final project, like that. All these details are available in examination reforms report that is available on AICTE website. So the first session was up to 12:30. I am almost there. This is the last slide. Again, I would like to repeat, assessment drives student learning. George Miller, and another is Donald Melnick, curriculum instruct teacher what to teach, exam instruct student what to learn. Okay, if you want your student to learn higher order abilities, if you want them to master the professional outcomes, then bring these things as part of assessment. Then only student will pay attention to and learn and become employable graduates. Okay, with these words, I will end this first session. Uh, then let us reassemble at 12:45. Take a 45 minutes break, freshen up, eat something, and with full energy, attend the second session. Okay, we are meeting at 12:45. If you have any questions, you can type in the chat window. So as soon as I start, I will answer them. Then we can start with the second session. And now we have 15 minutes break from 12:30 to 12:45. Thank you. Don't disconnect. Be online. After 15 minutes, you can come and resume. So welcome back participants, teachers from Engineering College and Polytechnics from Telangana and Bihar. Welcome to second session of day 1. In the chat window, you can type if you are able to hear my voice and see the slide clearly. Let me have the feedback from a couple of you. Okay. Okay. Thank you, Srinivas Rao. Thank you, Sunita ma'am. Thank you, Jayashree ma'am. Dr. Gunshekar Reddy. Okay, another compared to morning session, another 15-20 people should join. But let us not waste time, otherwise we'll close very late. Instead of that, let us start. So in the first session, I gave the overview of the entire exam reform policy document, right from the what is the need and what are the key drivers, what are the issues it has dealt with, and what is the importance of two-step process, and how to connect the assessment question with the performance indicator, and how it's going to bring clarity to the understanding as well as assessment. Okay. Now let us expand each of the things. The one thing is about the outcome-based education and understanding the graduate attributes of the program outcomes or competency performance indicator. Before we implement the exam reforms, so first we have to understand these elements which are part of this entire exam reform policy document. Once we understand these things, then the implementation will be effective. Okay. So here we are going to study about need for outcome-based education. As I said earlier, outcome-based education itself is a 2 days or 2.5 days workshop. So here I have listed only the 5 reasons why an educational institution should implement outcome-based education framework. Some of the things overlap with what I have already explained. So I want to be brief on this slide. To remain competitive at global level. Earlier I said both developed and developing countries have already shifted to this framework. Because of that, the quality of graduates has improved because these outcomes address knowledge, skill, and attitude required by the 21st century employers, and they also address the higher order abilities as well as professional skills. Because of this, the their students are graduates are becoming better than our students. So if you want to be remain competitive at a global level, we don't have any other choice. Without any delay, we have to implement outcome-based education in our country. Then second, to remain as a permanent signatory of Washington Accord. See, now we say that we are a permanent signatory of Washington Accord, but the journey was not that easy. In 2007, we were given temporary membership of Washington Accord and said in 2 years' time, you demonstrate your accreditation process in your country is based on outcome-based practices. But India failed to demonstrate in 2 years. Again in 2009, they extended the temporary membership by another 2 years. By 2011 also, India failed to demonstrate. Because very few institutes are aware about what is outcome-based education is, what the program outcomes are, what POs are, what is CO. Even if you know how to calculate attainment was not known. So that itself took time. Even in 2011 also we failed to demonstrate. Ultimately things started working, few institutions started practicing, and later in 2014 on June 13, India could demonstrate to an expert team from Washington Accord that its accreditation process by NBA is as per outcome-based education practices. So when they are successfully demonstrated, India became a permanent signatory of Washington Accord. Again in 2019, that period was getting over. Then again another team of Washington Accord expert came. They visited two institutions. One is our institution, another is in Tamil Nadu. And since our performance was good, again they extended the permanent membership for another 5 years. Okay. Uh, so it is not just easy to become permanent signatory. It is also not easy to remain permanent signatory. Why you have to remain permanent signatory? Once you are permanent signatory of Washington Accord, then our degrees will be recognized globally. Okay, the mechanical degree offered by tier 1 institution in India will be recognized by other member countries. Okay, so there is equivalence of degrees, same level. Even though our curriculum may change, the way we teach may change, how we examine may change, but yet because our both are permanent members of Washington Accord, our degrees are comparable or equivalency is established. Second is the mobility of engineers. You know that America is such a number one economy in the world with the 22 to $23 trillion economy. Ours is between $2.5 to $3 trillion economy, and our Prime Minister wants is to become $5 trillion economy by 2025. Okay, so we are 1/10 of economy of US. But if you look at the engineering graduates enrollment, America undergraduate engineering enrollment is 1 lakh, 100,000 students per year. In our country, it is somewhere between 12 to 15 lakhs per year. Okay, so 10 times bigger economy, just 1 lakh students, whereas 1/10 of economy, but 12 to 15 times more engineering students. So where are the jobs? So if we our degree can go to and they can market said here not try another hello now. I have changed the network connection. Is it okay? Okay, thank you. I will continue. So India can remain permanent signatory only if NBA can prove that its accreditation process is based on outcome-based practices. And NBA can prove only if we practice OBE at our institutions. So again, something happened. Administrator disconnected you. Okay. Sorry for that interruptions. I don't know why it is happening. Uh, Hope now it is okay. So to get NBA accreditation, we have to practice outcome-based education. So there is a need to understand OBE and to implement it. Then another reason is to adopt an education framework that helps in building learner competencies and makes students lifelong learners. See, earlier when education was referred at international discourse, they used to say that education is transfer of knowledge from teacher to student. But now that definition is no more valid. Now when they refer to education, they refer it to as a framework that helps in building learner competencies and makes students lifelong learners. And our traditional method of teaching doesn't address competencies and lifelong learning. But OBE addresses both the competencies as well as lifelong learning. In fact, one of the program outcome is lifelong learning itself. And all the competency what we are talking, they are also part of the OBE framework. Therefore, OBE framework is very, very essential to be implemented, and that is the need of in our country as well. And finally, to make students more employable by equipping them with knowledge, skills as required by the employers. Now only we said why they're employable. They are not employable because they are not trained, and also they are not trained in professional skills. So because of that, the students were not employable. But if you implement OBE, it addresses higher order abilities as well as the outcomes which are competencies which are expected from employers. Therefore, graduates will become more and more employable. In fact, even in India, technical graduates are their employability has increased to 50 to 60%. Earlier 20 to 25%, now it has become 50 to 60%. That itself is a proof that implementation of OBE is paying, or dividends are rich. Okay. So what is OBE? So OBE is outcome-based education, is student-centered curriculum design and instruction model. Here important is student-centered. The traditional method is teacher-centric, whereas outcome-based education is student-centric. So it is a student-centered curriculum design and instruction model that focuses on what students can actually do after they are taught. Okay. So therefore we say OBE shift the focus in education from teaching to learning. Okay. You shift the focus in education from earlier as a teacher we used to say that this subject is allocated to me. I have to take 40 lectures in this semester. I have covered and 8 chapters I have to cover. And once I do, I used to say that I have covered 100% syllabus. But whether my coverage of 100 syllabus has resulted in student learning, that never used to talk about it because you're teacher centric. But now OB say that, okay, gentlemen, you might have taken 40 lectures of these subjects. You may be regular in conducting classes, but whether it has resulted in student learning or not. If it has resulted in student learning, your teaching is effective. If it has not resulted in student learning, your teaching is not effective to that extent. Therefore, success of teaching is measured by students' learning. That is the difference. In traditional method, it is teacher covering the syllabus. In OB, it is students demonstrating his learning. Therefore, when we write COs, we write at the end of the course, students will be able to. Not teacher is able to. Student is able to. So student is, if you learn, then only you will be able to do something. So therefore, OB shift the focus in education from teaching to learning. So in OB philosophy, at the center we have this program outcomes or the graduate attributes. These graduate attributes in turn guide what should be the content, that curriculum design, what should be the pedagogy, that what are the teaching learning methods, and how we come to know that what we are taught is learned by the student, that is what should be the assessment strategy. So a core of the OB philosophy is these outcomes, which in turn guide the content, delivery, and the assessment. So if you look at the difference between the traditional method and the OB method, in traditional method, teacher is considered as sage on the stage. That is, we go to the classroom as if you know everything and stand on the platform in behind the podium. Then for the next 60 minutes, we pour our knowledge into the students. That is, we are all knowing sages. We pour our knowledge to the student. Therefore, it is called a pour it in model. The traditional teaching method is pour it in model. Whereas OB is about keep it flowing. Here you can see the teacher and the students. The knowledge comes from teacher to students and it goes back from students to teachers as well. Then you may say that how students are teaching me through the questions. They ask some questions which we are not be knowing. You do extra effort to learn, or you might have given explanation. The students say that he has not understood. Then you try to think of more and more examples and go back to class and give better explanation. So you also learn. Then another way is you are teaching a particular course. You have downloaded 60 peer reviewed papers. You don't have time to read. Give one paper to one student. Give 1 week time to them. Ask them to read and give a 5 minutes talk on what the paper is about, what are the salient features, what is the main objective, what are the conclusion. Based on that, you will come to know which are the papers that are required for your research or the subject what you're teaching. You also learn many things, and if you will also come to know which are the good ones on which you have to spend a little more time. So teaching, your knowledge also improves. Students also learn, they also become self-learners. Okay, okay. That also add to the lifelong learning ability of the student. In this way, the traditional method where he is the sage on the stage, it moves to a collaborative learning, where the teacher is no more a sage, he is also a facilitator or a mentor of the students. He guides the students. He helps them to explore, learn by doing, learn by exploration, rather than giving all the answers himself or herself. Okay. So with this little bit of discussion will be, let us move to understanding graduate attributes. What are these graduate attributes? These graduate attributes are the sets of competencies. These competencies are related to knowledge, skills, and attitudes that all learners, that means all students, are expected to demonstrate by the end of the program. By the end of the program is by 4 years, end of 4 years, they should be able to demonstrate all these 12 mandatory program outcomes as well as program specific outcomes. That is, demonstrate means the competencies associated with these POs and PSOs. For better understanding, these graduate attributes are grouped into three: knowledge, skills, and attitudes. Okay. What do we mean by knowledge? Knowledge means the fact they know and the concept they understand. Skill means they use in managing and applying their knowledge. As I said many times, we'll be knowing how things work, but if something goes wrong, we don't know how to fix it. So always I give the example of a PhD holder in internal combustion engine. He knows everything about internal combustion engine, petrol engine, diesel engine. Okay, what are the compression ratio, how the air fuel mixture mixes, okay, how the ignition starts, how the flame propagation takes place, how the reciprocating motion of the piston get converted into, okay, rotary motion of the wheels, everything he knows. He is going in a car. He has all the knowledge, okay, and car stops. In spite of knowing everything about engine, transmission system, everything, he cannot fix. He has to call a mechanic who is not even an engineer. Many times he will not be even a graduate. He comes and then fix the problem, and this PhD holder continues journey. That means the PhD holder has the knowledge, but he lacks the skill. He don't know how to apply his knowledge in solving that problem. Okay. So therefore, the 21st century employers say it is not the knowledge. Along with knowledge, we want to also want skills in the students. So you give them more and more experience, knowledge, internship exposure, so that they develop the skills. Then why? What is the role of this attitude? Attitude that dictates the goals towards which their skills and knowledge will be directed. See, what will happen is, even though a person is having knowledge and skills, if the attitude is negative, he will not use that knowledge and skill for the benefit of the mankind, rather than he will use that knowledge and skill to harm. For example, two groups of computer science engineers both have the same level of programming skills. They have the knowledge and skills at the same level. One group is having positive attitude, another is having negative attitude. The one with positive attitude develop the apps which will help the millions of users. Take for example the IRCTC railway app, how it has made the life simple. In fact, many of you may not be knowing. Earlier, we used to go to railway station, stand in queue for hours to book our ticket. And many times, by the time we come very close to the window, the booking will be over. Again, we don't know what to do. Again, come back home, discuss with the parents. Again, go back and reserve. But now it is not like that. Sitting in the comfort of your house or office, you can check whether reservation is available on a particular date, particular train, which whether is lower berth, upper berth, middle berth, everything you can decide and book it. So, what a wonderful app they have developed. But you think of another group of engineers, computer science engineers who have negative attitude, they develop a virus which will harm so many users across the globe. So even though knowledge skills are there, if attitude is not positive, they will not be a good productive member of the company. Therefore, the 21st century employers look for knowledge, skills, and attitude in their graduates. So now it is our responsibility, because 4 years they are spending with us. Within these 4 years, we have to train our students in all three aspects. For little more clarity, I have grouped them into 4 baskets. The 12 program outcomes, I have put them in 4 baskets: 1, 2, 3, 4. First basket is knowledge oriented, in that program outcome 1 is there. That is, at the end of the program, students should be able to apply knowledge of mathematics, science, and engineering fundamental to solve complex engineering problem. So all the courses which help students to solve complex engineering problem by applying engineering fundamentals or the mathematics or this science laws, that comes here. Then problem solving groups. If you want to improve the problem solving skills of the students, focus on program outcome 2, 3, and 4. Try to remember them. 2, 3, 4. Problem. They should be good in analyzing complex engineering problems. They should be good in solving or developing solutions for complex engineering problem. They should be good in investigation of complex engineering problem. If you train them, they will become they develop skills in solving problems. If you want to focus more on skills, then focus on program outcomes or graduate attributes 5, 9, 10, and 11. They should be good at modern tool usage, individual teamwork, communication skill, project management, and finance management. And if you want to improve the attitude of the students, focus on graduate attributes 6, 7, 8, and 12. What is the role of engineer in society? And what is the impact of engineering solution in environment and sustainability? What is the role of ethics? Okay. There are code of ethics for mechanical engineering, ASME code of ethics for mechanical engineering, IEEE code of ethics for electrical and electronics engineering, and code of ethics for biotechnology. Like they're there. So you should, if you Google, you will get it. You understand that ethics and teach your students. If you are not aware, if you are not comfortable in teaching, then you can invite somebody from industry related to your program. Let that person train your students. So in outcome-based education doesn't mean that everything will be taught by us only. Okay, here learning is important, but from whom, where, how student learn is not important. But he should learn. Finally, lifelong learning. So he should understand that learning doesn't end once he get the degree. That is just a beginning. Okay, as the technology changing rapidly, he should learn the new technology on his own, either by attending conferences or by MOOC courses. Okay, or attending the training workshops. So by various means, he has to update himself and remain current. So all this depends upon the attitude of the student. If attitude is positive, he will make effort to learn new things. Otherwise, he will not do. So these are the 12 graduate attributes. In the knowledge oriented, we have number one. In problem solving skill group, 2, 3, 4. Skill oriented, 5, 10, 11. 5, 9, 10, 11, 9, attitude, 6, 7, 8, 12. So these are the expectations of the 21st century employer, right from engineering knowledge to lifelong learning. So parents with good faith send their students to our college. It is our responsibility of all the teachers in the department. Within 4 years, we have to train our students in all these program outcomes. And if you define another 2 to 4 program specific outcomes, you have to train them in them also. As earlier I said, out of 12, 5 we call technical outcomes, another 7 we call professional outcomes. Many times teachers have doubts whether graduate attributes and program outcomes are they different or same. So they are one and the same. Whether you call them as graduate attribute, program outcome, they are one and the same. You can use them as synonyms. In place of graduate attribute, you can use program outcomes. In place of program outcome, you can use graduate attribute. They are one and the same because generic in nature and they are common to all undergraduate engineering programs. Okay. So who defines them? Earlier I said they are defined by accrediting bodies like National Board of Accreditation, like ours in country, ABET in US, of different accrediting body in different countries are there. They along with association with professional societies like IEEE, ASME, ASC, different professional societies, they define graduate engineering programs. The graduate attributes as stated by NBA are in the spirit of program outcomes. So some academic bodies call them graduate attributes, some call them as program outcomes. So whether you call whichever name, they are one and the same. So now to understand these graduate attributes or program outcomes, what we should look. So these graduate attributes 12 in nature for 4-year engineering programs, and there are 7 in number for diploma. The same 12 are clubbed and converted into 7. Okay, tomorrow when I give the second presentation, there I will show how they have been clubbed. Okay, so now let us try to understand these 12 program outcomes. Now, even though the program outcomes are same, they are shared with all the colleges and every department in every engineering college. But because of the attitude of the teachers, they try to look at them in a different way. First, let us take as one set of teachers how they look at them. Okay, they look at here engineering knowledge, apply the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problems. So engineering graduates or by the end of the program, engineering graduates will be able to apply. That's how you have to read. By the end of the program means 4-year program. Engineering graduates will be able to apply the knowledge of mathematics, science, and engineering fundamentals and an engineering specialization to the solution of complex engineering problems. So they will not think in terms of competency. They think, okay, mathematics, okay, we have 4 mathematics courses. First semester, second semester, third, fourth, we teach mathematics. Okay, this program outcome is taken care. Science, okay, we have physics, chemistry subjects taken care. Engineering fundamental courses, okay, we have basic mechanical engineering, electrical engineering, electronics, computer programming. So we have many courses. Program outcome 1 or graduate attribute 1 is taken care. That is their approach. It depends upon their attitude. Okay, that's why attitude is also important, not only for students, even for teachers. Now, second program outcome. So, what is talking? Identify, formulate, review research literature, and analyze complex changing problems, reaching substantial conclusions using first principles of mathematics, natural science, engineering science. And from mechanical, so I take an example from mechanical. They say that we have some heat transfer subjects, fluid mechanics subjects. So once we give a subject the problems in that, he need to analyze before solving. Even for that matter, OR also, some of the problems will be scenario based, wherein unless the student analyze, he will not formulate the problem itself. Okay. Only once you formulate, then only he will be able to solve. So there are some subjects are there in that he will able to formulate and then solve. So those subjects will map with this PO2. PO2 is taken care. So here you can see this teacher's attitude is only to map the subjects with the program outcome. Why they want to map? It is a requirement of accreditation. NBA says prepare a program articulation matrix, make a list of subjects in first column. In subsequent columns, you write PO1, PO2, PO3, PO4, PO12, then PSO1, 2, whatever number you have written. Then map which subject is mapping with PO1, with PO2, PO3, like that. So all they are interested in only mapping. Okay. Then design development of solutions. Again, they see even they don't read properly also, they say that okay, we have machine design 1, machine design 2, and in mini project or final project they do projects. So all these courses will map with the PO3. PO3 is taken care. Then conduct investigation of complex problems. Use research-based knowledge and research methods, including design of experiments, analysis, interpretation of data, and synthesis of information to provide valid conclusions. Here they don't read it and try to understand what is design of experiments, analysis. Simply say that they look and say, comment, we have so many lab courses. Almost every semester we have two labs. We will map all the lab courses with the core, PO4. So this PO4 is taken care. They don't think that in our labs, we don't train our student to design an experiment. Already experiment designed only will do as per the procedure he will conduct. Maybe in some he will analyze, interpret, and submit the journal. Otherwise, more of conduct and presentation of the results. Do some sample calculation and submission. There is no design of experiment. They will not even read also completely. They simply say that we have lab courses. We will map all lab courses with the PO4 done. Modern tool usage. Again, you say, okay, we have CNC machine lab, we have some metrology lab. Metrology lab, we have purchased some coordinate measuring machine, or you take to some industry where they're using latest tools, and we expose our students to that. And okay, we map that metrology course or any workshop course where they're using tools. We'll map that those courses with PO5. So PO5 is taken care. Then engineer society. Here a little bit problem comes then. So there is no specific subject which they can map. In some cases they have in first year they're introducing some courses like social innovation that we have done, where we connect the students with societal problems. If teachers have become very smart in these institutions, what they do is, if they don't have anything, they will map that program outcome with final year project or some mini project. So they'll say that these projects will take care of these POs. Okay. Then 7, environmental sustainability. Again, easy way is if you have environmental subjects, or the Supreme Court has made a mandate earlier, this Constitution of India and environmental science, a mandated course, if they are still teaching, they'll say that we'll map that course with this. So PO7 is also taken care. Ethics, then they say they don't have any subject about ethics. Okay, map it with the project. Along with that, they say that we have purchased one this what do you call software, plagiarism check software, and we subject a student project to that. And if plagiarism is more than certain percentage, we ask them to revise the write-up. Through that, we teach them ethics, and also we ensure that students don't copy in the exam. That is also ethical behavior. We ask them not to copy the lab journals or the home assignment. Thereby, we create awareness about ethics. So in this way, they say PO8 is taken care. When it comes to individual teamwork, they don't even read also. They say that, yeah, our students do projects in teams, and therefore those courses will map with PO9. Then when it comes to communication, we have seminar course, and also during project 2, students make a presentation. They write lab journals and finally their project report. So PO10 is taken care. Project management, final management, again, the final project, mini project only map with the project management if they don't have any project management course. Okay. Anyway, as part of project, students do the budget. So that itself they say finance management. Okay. Then lifelong learning, they say that we in the subject one chapter we don't teach, we ask the student to learn himself and write the answers in the examination, or we ask them to use one software which is not taught in the class for his project. Thereby he can map that lifelong learning. So this is how these people are more interested in mapping the courses with the POs and PSOs. If they think that they are able to map the courses, their work is done. So this is how they implement it. So if they do like this, if they do only mapping of the courses with the course outcomes and continue to teach the way they were teaching earlier and continue to assess the way they are assessing earlier, even though they claim that they implement OBE, the quality of graduate doesn't improve, and they start blaming OBE. See, they said by implementing OBE, quality of graduates has changed, but we are not seeing anything much difference in our students' quality. Because it has happened, you are not understood the program outcomes properly, you are not implemented properly. So now I will take the second set of engineers who have a better engineering college teachers who have better attitude, who have positive attitude. How they also have the same 12 program outcomes or the graduate attributes, how they look at them and how they develop the clarity of focus, that I will show you. For example, I have taken only one because of if I cannot explain all the 12. So one, that is communication, which if you are belonging to any engineering discipline, whether engineering or diploma, you can understand. That's why I selected this. Okay. So here you can see communicate effectively on complex engineering activities with the engineering community, with the society at large, such as being able to comprehend, write effective reports and design documentation, make effective presentation, and give and receive clear instruction. If you give this to a teacher or student, it's so difficult to understand what are the expectation of this program outcome 10 or graduate attribute 10. Therefore, in the two-step process, first you write the competency associated with it. So what are the expectation of this outcome? One is students should demonstrate an ability to comprehend technical literature and document project work. That is here. Able to comprehend and write effective reports. This is written as a competency or ability here. Is it enough? No. When you say the student has this competency, only when he fulfills these performance indicators. You give an activity, give a technical literature or published paper, let him read, understand, interpret, and then explain to you. When you do that, then if he's able to read and understand, interpret technical or non-technical information, then you can say, okay, he has this ability. Then if he's able to write well-constructed, well-supported written engineering document, it could be lab journal, project report, okay, he has this ability. Then if we can create a flow in a document or presentation, a logical progression of idea, so that main point is clear. You might be, as a teacher, you come across students. Some students speak a lot, but you will not be able to understand what he is able to explain. Some students explain in such a way that it becomes very clear that what he is trying to explain. So if he is able to demonstrate these 3 abilities, that means he has this competency. So, and whether you have to struggle a lot in writing competence performance, no. As I said, already this competency and performance are given in the policy document. Only you have to read and understand them. Okay, this is the first competency. Second competency is this: demonstrate competence in listening, speaking, and presentation. Communication does not mean only speaking, it also means listening and presentation. Then, what are the performance indicators associated with it? Listen to and comprehend information, instruction, and viewpoint of others. When somebody is explaining, if you are able to comprehend that information, understand it, and you give your own and their viewpoint also, and give your viewpoint, then that means you have that ability to communicate. You are able to listen, you are able to digest that information and their viewpoint, and then you can present your viewpoint. Okay. Then second performance indicator, deliver effective oral presentation to technical and non-technical. So it is, if you think that non-technical is not needed, you can stop at deliver effective oral presentation to technical audiences. So during that technical project presentation, you are there, you listen, and then judge which student is good in oral presentation and who is not good. Many times giving marks is difficult. Then you can think of red, yellow, and green signal. Simply in front of this PI, you can write R, Y, or G. Later on, you can convert to marks. But since the time required to assess is not much, the student is explaining 5 minutes. One student will explain his project. Another 5 minutes, another student. During that time itself, you have to judge whether it is green, red, or yellow. Okay, so either he is very poor, he's okay, or he's fantastic or excellent, like that. Okay, so if he's good in both of these, then he has this competency. Finally, the third competency associated with communication skill is demonstrate the ability to integrate different modes of communication. Okay, it is not just oral talking with somebody. He should be able to create engineering standard figures, because if he is talking about some machines, then it should be engineering drawing. It is not just some artistic sketch. He should prepare a report and drawings, and these drawings should be complement to the written matter. Just for the sake of putting some figure, one should not put. The figures, drawing, everything should be correctly placed so that it makes the understanding for the reader, okay, easy to understand the content for the reader. Okay, so that is one performance ability. Second is use a variety of media. Right now I'm using using WebEx platform. I'm using audio visual presentation. I know how to make use of the PPT, how to prepare a PPT, all these things, modes, internet I'm using, and communicating my presentation to you. So if you want to communicate, then this is also one of the competencies required. It is not just read and understand and write reports, or listen to somebody and understand their viewpoint, or make your own presentation, use figures, or use a variety of media to convey the message. Once you have all these things, then you can say our students have mastered communication skill. So if the teacher, earlier also they were teachers, they said the moment communication, they said we have a student give seminar, our student give presentation to projects, the final project, mini project will map with the CO, PO10. But these teachers are not like that. They read this, then wrote the competency for each of the competency. They wrote the performance indicator for each of the performance indicator. They thought of an activity. Activity here, reading a paper and presenting it. Some journal writing, project writing, like that. So they thought about a activity through which they are able to say a student is excellent, average, or below average, like that. Okay. So when teachers themselves go through this process of understanding a program outcomes in terms of competencies, in terms of performance indicator, and then assess the students using proper use of rubrics, then definitely quality will improve and students will become more employable. So what is shown for this one should be done for all the 12 POs and 2 to 4 PSOs. And as I said earlier, all for 12 POs it is already done. Only you have to read and understand. Then there is third set of teachers. Second set itself is good enough. Okay. If you want to do that extra, that what we did, that I'm sharing quickly, we went beyond the stage of writing competencies and performance indicator. It is the experience what we went through 10 years back. Okay, so it is not the present one. So that experience I'm sharing. So when you started understanding the outcome, that led to the creation of a new subject itself. Because since 2007 we were autonomous college, so we were able to design a course and introduce it on by ourselves. We are not affiliated college, so we had that freedom to introduce new course. In those time, still we were referring to even ABET, our NBA was also referring to ABET outcomes. ABET has 3A to 3K, A through K. A, B, C, D, if you count, A to K is 11 outcomes they were having at that time. Now 11 they have reduced to 7. Okay. So at that time, the third outcome was about design. An ability to design a component system or process to meet desired needs within realistic constraints such as economic, environmental, social, political, ethical, health and safety, manufacturing system. Very lengthy statement. Then at that time, 10 years back, what we thought was, it is lengthy statement, let us break them into elements. We are not talking at that time competency, we are breaking them into elements. So since this outcome talks about component, system and process, that the first element refers to ability to design a component. Second element, ability to design a system. Third element, ability to design a process. Let us understand the process what we use so that you can also use for the present outcomes, so that you will get more insight into these outcomes as well as you can come out with better activities so that your students will learn more about these outcomes and become more employable. That is the idea. So what we did at that time, I was the head of the department of mechanic department. So then I asked my colleagues, let us ask ourselves, do our students have the ability to design a component? They said yes. We have a content that is where we train our students to design a component. Whether our students are able to design a drilling machine or a milling machine, entire machine, they said no. Whether they have ability to design a process, no. Let us, since there is a or is there, let us focus on only the ability to design a component or system. Let chemical engineers let them design a process. Okay, that is good enough. That is nothing wrong in it. So we have to train our student in designing a component and system. So at present time, 10 years back, we were training our student design a component but not system. Okay. Next, what we did, since I said, since there was concept of competency was not there, we were evolving the things to understand these program outcomes. Then we took the first element, ability to design a component. Then we wrote ourselves some PI code. PI code means since it is a third element C and its first element 1, out of that first indicator C1A, C1B like that. First indicator, second indicator, third indicator of element 1 like that of program C. Then I ask the question, what do you mean by ability to design a component? If I say that my student has the ability to design a component, what ability he should have? Then the people who are well versed with design, they said these things. If you have a teachers who are good in machine design, they may write much better than these things. Okay, but we have to work with the expertise that is available in the department. So my faculty said these things. I said, okay, fine. So when you say that students have the ability to develop a component, then they said if they have these things, then I can say that they have the ability to do component. Since you belong to different disciplines, let us not go into the details of it. Let's understand the process. So take an element, write the indicator. Take an element, write the indicator. And ability to design a system, what are the indicators. Okay. So having written the indicator, did we stop? No. Then this template was prepared and gave it to my faculty. So here you write the program outcome, what is given as per ABET. MEPO means mechanical engineering, program outcome. C is the third one. Okay. Because it's specific to our college, we are writing at that time in this way. Then we used to take first element. Then we used to take the first indicator related to this. Education strategy means my faculty should write in which of the courses we are teaching have some content related to this performance indicator. Right. Then given an option in which subject you want to collect the data means you will ask question, student will answer, and that data you will collect. So that subject name they have to write. And in order to make sure that students become familiar with this performance indicator, which activity will you give? Then they said we'll give a PI specific assignment problem so that at home let them do. Then looking at this stage, current stage, what is the perceived weakness, gaps, or opportunity? 10 years back, if you look at this, is it a strength, weakness, or opportunity? Then they said ability to determine design parameters. That then is a weakness. We are not giving much stress while teaching. We are only taking to do the process of designing, but we are not giving much emphasis on this. How to determine design parameter based on functional requirement. Okay, fine. Make a note of it. Similarly, again, second performance indicator element one, in which subject, where you want to collect data, what activity, is it a weakness? Then they said, identify design constraint is a weakness. We are giving the constraint, but we are not asking the students to identify the constraint. That is the weakness. Then third component, expressing appropriate units for the design parameters is a weakness. Usually at that time, tell students you to write 20 mm, no tolerance, and forget about the finish, heat treatment, all those the geometric tolerancing, uh, GT and T, what do you call? Geometric tolerancing was missing. Okay, so therefore, that is also weakness. Then take the second element, it's the indicator where the content is there, where you want to collect data, what activity, what weakness, regular interaction with the guide of the weakness. First month, they interact with the guide. Once the problem is finalized, they vanish. Only in the last month they come, sometimes a ready-made project with some report. So very little interaction was happening. That is also weakness. Then another thing, subjects where the content is there, where they want to collect the data, what activity, present quality of the drawings do not match with the requirement of the manufacturing drawing. If you give the operators, machine operator, they would simply laugh. What is this? There is no tolerance mentioned, process is not mentioned, workflow diagram is missing. So all those things. Only some drawing is there, which is not at all meet the requirement of manufacturing drawing. That was weakness. The manufacturer, as per the approved design check. Usually during design, there is something, final project is something. In the design, it may be quarter HP, then final project, they may be giving half HP. Why? If you ask, sir, this was available in the workshop, so instead of spending money to buy a new one, we have used it. So forget about tolerance in microns. Even many times things used to measure in millimeters. So conference with the design parameter was not checked. That is also weakness. Able to recognize design needs. They were not knowing. Just once the problem is there, project is given, they used to start designing and fabrication. But they have to talk with the user, for whom you are making a project. Through a well-designed questionnaire, you have to collect the needs and constraints. How much money within the budget you want that, and what are his needs? What are the size specifications, weight specifications? Nothing. They just used to start project. Now we have to teach them that you, with a well-designed questionnaire, you have to understand the needs of the customer. That was the weakness. Then another thing was the ability to identify and understand important realistic constraint. Okay, that was the weakness. So not only for subject it should be program outcome. It should be for even mini project, final project also this should be extended. In this way, for each of the element, we used to take one performance indicator. We used to identify in which subject the content is there, where we want to collect data, what specific activity you want to give, then is it a weakness or a gap? Like this, used to study. Okay, so just paucity of time I am going through. Then having went through all the weakness, made the list. Then we had option either to change the existing subject or to design a new subject altogether. Since we are an autonomous college, we thought of designing a new subject itself. We introduced a new subject called machine tool design at sixth semester level and introduced it for all the students. Its scope was to familiarize steps to design a complete machine tool based on the given objective and to draw the layout and connect diagram in 2D using a software, preparation of assembly drawings as per industry standards, okay, carry out design calculations, prepare manufacturing drawing relevant geometry dimensioning and tolerance symbols, okay, to prepare bills of materials in Excel sheet, to draw the whole model in 3D using CAD software, and to prepare a project report as per the given format. So suddenly things at the end, it is a spindle of a lathe, you can see. Earlier they used to draw something, cylinder, at the end there is a circle, inner circle, outer circle, inner diameter, outer diameter, length, finished. That was their drawing. But once we implemented the new course we started, addressed all the weaknesses, then within one semester things changed. These drawings are almost equivalent to industrial drawings. That is how the OBE implementation in a proper spirit helps. Suddenly quality of drawing improved. Okay. And our placement officer started collecting these drawings, and whenever we're going, started showing this is the type of drawing our student drew. They have now knowledge of GD and T, so he could be able to attract better industries for our students. Another headstock assembly, you can see how wonderful it is. So OBE implementation depends. The first group of faculty, only mapping of courses the outcome. Second group of faculty, they wrote the competency, performance indicate, thought of activity, then implemented. Fantastic. The third went much beyond. They looked at what is the present practices, what are the weakness in them, and then fix those weaknesses, and things improved. At the end, now we could claim that our students not only good in component design, they're also good in system design. That's how OBE helps. Now, just to break the monotony, there are 12 program outcomes. Here is a question. They have 4 baskets. In which basket, which number falls? Only number if you write, fine. Knowledge oriented, which number? Problem solving skill group, which numbers? Like that. You can type. Like knowledge oriented, you can very easy. GA1. Like somebody, Jayashree Madam written, Shivaraj Narayan has written. Good. Then they write about problem solving skill group, which are the numbers. GA2, but not only one, there is another 2. Okay, 2, 3, 4. Krishna Kumari has written, Madam has written. That's correct answer, 2, 3, 4. No, 2, 3, 4 is correct. Okay. Since earlier you written 2, now you are written 3 and 4. Fine. So second question, now answer is out. 2, 3, 4. Now try the third question. Skill oriented group. Five, 9, 10, 11. 6, 7, 8, and 10. That is attitude. No, 10 is communication. Communication is a skill. Okay, because of time, I'm giving the answer. So 5, 9, 10, 11 is skill-oriented group. 6, 7, 8, and 12 is attitude group. So competency and performance indicator, I have already explained, taking the PO3 example. I don't want to spend much time here. Just I will take you through the slides. So as I said, design is a top-down approach, assessment is bottom-up approach. The missing connect is the how to connect CO with the graduate attributes or the program outcomes. Because there is a lack of understanding, the implementation of OB is not correct in our country. Now slowly the teachers in different engineering colleges and polytechnics are understanding how to connect with the policy document. Now things are improving. So because of lack of clarity, unrealistic assessment is happening. Even though people are getting accredited, they are showing the attainment of PO1 2.8, 2.9, 1.78 like that. But the since the connection itself is wrong, assessment is also not correct. And this already they explained. They are generic and high level, 50,000, 25,000. So I already told, so there is no need to repeat because myself has explained these things. So two-step process, competencies. Here the example is PO2, it's competencies. Then for each competency or take right the performance indicator already they have been explained. So there is no need. Then where you will find, if you download the policy document for all engineering programs except computer science, you will find from page number 15 to 19. And for the computer science, you will find from 29 or page number 29 onwards. Then what is mean by PI code? 1.2.1 means first one is refer to program outcome. Second number indicates a competency number. Third number indicates the performance indicator. 1.2.1 means first PI of second competency of first program outcome. Okay, this is how. Similarly, another example, 2.1.3 means uh, see these once the presentation is over, maybe a day or within a day or two, they will put the entire video on YouTube. Anytime you can check them. 2.1.3 means third, see, this is the first performance indicator, second, third. Third indicator of first competency, that is 1, and PO2. So first number refers to PO, second number for competency, third indicates for performance indicator. So for computer science, 29 to 33, but one printing mistake has happened. You all know how to write the content sheet. If it is 1, next subsection is 1.1, 1.2, 1.3, 1.4. Then subsection of 1.1 will be 1.1.1, 1.1.2. Under 1.2, there will be 1.2.1. Under 1.3, there should be 1.3.1. And 1.4, there should be 1.4.1. But copy paste, if you know, when you copy paste the bullets, the number gets changed. So because of that, the uniformity has lost in this. So before writing the number, you first correct them. Here for this PO1, I have done the correction. Even though it is 1.2, it should be, if it is 1, it should be 1.1. If it is 1.1, second component should be 1.2. Third should be 1.3, fourth should be 1.4. So you change the numbers and then use. I cannot do much because already printed. So only thing is AI should change and again upload it. But till that time, you make the changes and use them. So these for computer science, you can refer to 29 to 33. So 1.4.1 means again the first PO, first number, fourth competencies. Then this one means first EI. And once you understand what is the competency, what is the performance indicator, next you have to write the questions. Actually speaking, this arrow mark should be this way. Looking at the indicator, you have to write the question. But in India, number of colleges are more, number of teachers are more, and most of the teachers are not involved in providing consultancy. When you are not involved in consultancy, that means your exposure to real world problems is very little. In that case, drafting a question to suit a performance indicator is difficult. So what is the next best thing is select a good textbook written by a practitioner and look at the question which is appropriate this performance very as close as possible, then select that question and map that question with that performance indicator. So here one question is selected from a textbook mapped with this, another question it is mapped with this. Okay. Then how this two-step process works. Today I will tell in brief and tomorrow we'll do it in detail. Okay. So now this two-step process for every program outcome, we write the competency. For every competency, we write performance indicator, and we connect the performance indicator with the assessment question. That is what this two-step process is. Let us take the example of program outcome 1. Let us say there are 3 or 4 competencies. For easy understanding, let us take 3 competencies. One competence related to mathematics, one related to science subjects, that is physics, chemistry, another competence related to basic engineering subjects. Okay. Now, for each competency, there will be few performance indicators. Then assessment will be either continuous internal evaluation, internal assessment 1, internal assessment 2, or take-home assignment or quiz, whatever it may be, post-project. And there is semester and examination, 3-hour examination, or it may be a part of during the project you may ask questions. During lab exam you may ask questions, which will assess by rubrics. So these are all assessment questions. We have to connect with the PI. Now let us try to understand in the absence of two-step process what it means, and in the presence of two-step process what happens. So this is the thing. We have assessment, we have a course for which there is a course outcomes. Okay, let's take a course. Let us take a single variable calculus in order to bring more clarity. That means this subject talks about only calculus. Okay. Now, whatever number of CO you write, whether 4 you write or 6, all will be related to single variable calculus only. Okay. Whether you ask this question in inter-assessment test or semester and exam, the questions are related to calculus only. Now, there is a PI. This is a mathematics competence related to mathematics. One PI related to calculus. One PI will be related to students' ability to develop mathematical models. Then another PI related to probability statistics. If you want to specific, you can write one more PI related to Laplace and Fourier transforms. Okay. For electrical students, second order differential equation, calculus, those things are important. For mathematics, the mechanical students, mathematical modeling is important. For computer science students, probability statistics is important. For electronic students, Laplace and Fourier transforms are important. So depending on the program, you can write additional PI also. Okay. Now let's see this for calculus. You remember this for mathematical modeling, this for probability statistics, and another one imaginary for Fourier and Laplace transform. Now let's say earlier, let's say this two-step process is not there. You have a question either in inter-assessment or semester exam that you connect with the CO, and through CO-PO mapping you are connecting to PO. So if there is a question connected to one, and if one is connected to PO1, that means P1 is attained. But now, if I introduced two-step process, now what happens? CO1 only connecting to PI 1.1.1. Even if there is CO2, if there's a question related to CO2, that question will relate to PI1 because entire subject is calculus. If you ask question on CO2, that is also connected to PA 1.1.1. One more CO3 related question also this, CO4 related to this only. Then what happened? Now can you say P1 is attained? No. Out of 3, 5, 8 question, 8 PI, only one is attained. Now I cannot say P1 is attained. I have to wait. I have to take one more course where the mathematical modeling. Then this again I cannot say P1 is attained. Then one more course where probability statistics is attained. When all three related to mathematics are attained, now I can say the student is trained in mathematics competence. He has developed mathematics competency in mathematics. He can apply mathematics in solving problems. Now come to this. I have physics. This PI is related to physics. Only this now I cannot say this is attained. So only on competence, ability of applying physics laws, chemistry laws, then only I can say he has developed the competence to apply laws of science. Whether P1 is attained, still not completely. Then here the engineering fundamentals, basic electrical engineering, basic mechanical, basic computer programming, electronics like that. If I have all the courses and if there are questions and they are related to these PIs, when all these PIs are satisfied, then all these competencies are attained, then only I can say PO1 is attained. That is the clarity this two-step process brings. Otherwise, any one question, either in internal assessment or semester exam, that is related to CO1, CO1 is related to P1, P1 is attained. That's why OBE was not, even though you are implementing OBE, it is not giving results. So this we'll understand it more tomorrow. So by using the two-step method brings a clear understanding of the expectation of each program outcomes to faculty and students. Connecting course outcomes to performance indicators and hence to POs will be easy and accurate. So earlier what you are doing, course you are connecting with questions and a course with POs. Now in between question and course, PI comes. So whatever questions you have, first connect it to PI, then to CO, then to PO. Okay? Then once you have CO attainment, the same different COs may contribute to the same PO. Then by aggregating, you can show the attainment of PO attainment. So this method brings the clarity. Therefore, we say by mapping examination questions with performance indicator, we get clarity and better resolution for the assessment of COs and POs. So moment you come to know this question is connecting with only PI 1.1.1, still they have so many PIs to connect. Without the two-step process, you will not even come to know. Question CO, PO. Any question, if as long as CO is connected to the PO, PO is attained. So now this clarity will be there. So quickly just go through the questions. Since already we are very close to 2, I'll give the answer also. OB stands for outcome-based education. In OB, focus is on learning. In OB, student is active, he is not passive. OB is student-centric. And what are the advantages of becoming permanent signatory of Washington Accord? One is international recognition of degrees and international mobility of graduates. And what are the 5 reasons for adopting OBE? One is it improves the global competitiveness of our graduates and will continue to remain permanent signatory of Washington Accord. Our programs will get easily NB accreditation and it helps to build learner competencies and equip students with knowledge, skill, attitude required by the employers. After going through 2 sessions, you have to say, are you convinced about the need for outcome adopt OB framework in your university? That is, choice is left to you. If you say yes, that means you appreciate the 2 sessions what I have delivered so far. Thank you for writing yes. Final quiz and we are closing for today. in two-step process is proposed to enhance resolution of program outcomes. Two-step method brings a clear understanding of the expectation of each program outcomes to faculty and students. Many times we think that this is done only to bring clarity to students. No, even we faculty, we also need this exam document is required to understand these program outcomes in a better way. When you understand, then only you can design different activities through which students will learn better. Then is there any guideline regarding number of competency and PIs? No. But till you understand thoroughly, you can use what is given in the policy document. As I said, the computer science may give more stress on PI related to probability and statistics. E and C may give PI related to Laplace and Fourier transform. Electrical may give to linear algebra and calculus like that. Mechanical may give to modeling. So depending on your need, you can add or delete one of the PS. So there is no hard and fast rule that number of competence in PI should be only this much. You can add, delete, modify, it is up to you. Therefore, we say these are guidelines, not mandatory. The word guideline is used here. Then different competence would generally require different assessment measures. To test students' ability to analyze is different assessment. Then to test his teamwork skill, communication is entirely different assessment measures. A realistic observability and measurability of the POs at course level is very difficult. Therefore, this two-step process comes in picture. Connecting course outcome to performance indicators and hence to POs will be easy and accurate. Okay. By mapping examination questions with performance indicator, we get clarity and better resolution measurement for the assessment of COs and POs. Okay. So with this, I end. So the time was up to 2 o'clock. I took 2 minutes extra because of many internet problems in between. Okay. You can, if you want to spend some time on question answer, you can ask question, or else tomorrow at again 10:30 we can meet at the right time and start preparing the model question paper for a subject which you are comfortable. So if there are no, thanks for your appreciation. If there are any questions, fine. Otherwise, we'll wind up for today. And tomorrow at 10:30, my colleague will start with Bloom's taxonomy. And again, second session, I will come. I will talk about how to design a question paper and how to design questions which will address higher order thinking skills like analyzing, evaluating, and creating in lab as well as post projects, final year projects. Okay. So thank you for your participation in big numbers. Here I will stop sharing. Okay. Thank you very much. We'll meet tomorrow.